Now we're going to work on drawing Lewis structures of molecular compounds or polyatomics. So the first thing that we're going to do is we need to count the number of valence electrons. For a polyatomic ion, we're going to add 1 electron for each negative charge. But don't worry about that. We'll come back to that later. We need to know the number of valence electrons because somehow all these atoms have to share the valence electrons so that everybody ends up with a full outer shell. That's going to be 8 electrons, unless you're hydrogen, in which case you only need 2. So the way we're going to do this, if you follow these steps, 1, 2, 3, 4, 5, you will always get to an answer that's correct. First, we're going to draw single bonds around the central atom. I will always tell you what the central atom is. Each single bond uses 2 electrons. Then we're going to place the remaining electrons on the outside atoms to complete the octet rule. Everything moves in pairs. Now, remember, H can only have 2 electrons. 4, use any remaining electrons to fill the octet on the central atom. And 5, if the central atom lacks a full octet, share lone pairs from the outer atoms to form double or triple bonds. So we're going to work through these following the steps, and I'm going to work from left to right. Step 1, count the number of valence electrons. So we have a total of 8 valence electrons, and I'm going to abbreviate that BE in the interest of space, okay? Step 2, I've told you oxygen is in the middle, so we're going to connect by single bonds. And so we look at how many of our electrons have we spent so far. So we can think of that 8 valence electrons as our budget. So far we have spent 4 valence electrons. Step 3, we're going to place any remaining electrons on the outside atoms to complete the octet rule. Well, we're going to skip this step, and that's because H is full, okay? H only wants 2 electrons. Do not make it have any more electrons. So we're going to skip step 3. Now, step 4, use any remaining electrons to fill the octet on the central atom. So I have 4 electrons left. Everything goes in pairs. Pair, pair. All right, I'm going to check out my central atom because step 5 is if the central atom lacks a full octet, share lone pairs. And I look at oxygen and it's got 2, 4, 6, 8. Oh, oxygen's happy. So I do not need to do step 5. So I am done. This is the Lewis line structure for water. All right, let's do CO2. So I've got the shorthand rules so you can still see them up there in the corner. So we're going to do CO2. We're going to count the valence electrons. We need to know our budget. So 4 from the carbon plus 2 times 6, and that's 16 valence electrons. That's our budget. I've bolded carbon to tell you that that goes in the center. So we have C, O, O. All right, let's see how many we've spent. So each line represents 2 electrons. So far we've spent 4 valence electrons. It says place any remaining electrons on the outside atoms. So we're going over to step 3. Everything goes in pairs, and you will always have enough to fill the outside atoms. So 2, 4, 6. That's 8, 10. Okay, so you always have enough to fill the outside, trust me. So let me count how many I've spent. 2, 4, 6 on the first oxygen. And then I have 8, 10, 12, 14, 16. 16 valence electrons. I've spent my entire valence electron budget. Okay, now I'm to the next step. And I go, oh, wait a second. Let's see what's going on here. Use any remaining electrons to fill the octet on the, oh, you know what? I have to skip that step because I don't have any electrons left. All right, let me erase that. I got to skip that step. Skip. I'm out of electrons. Okay, well, let me try the next step. So here I am. Okay. And it says, if the central atom lacks a full octet, share lone pairs from the outer atoms to fill up the inner ones. Oh, okay. So what I can do is I can take that pair and I can share it. And I can take the pair on the right and I can share it. And now my structure looks like what I'm drawing right now. There we go. So let me color code what I did so you can track what's supposed to happen. So I took that lone pair and I turned them, each of the lone pairs, into a shared pair. All right, we're going to do some more. Got the shorthand rules up at the top. We're going to do SO3. So the first thing we do is count the valence electrons. So we have 6 from sulfur plus 3 times 6 from the 3 oxygens for a total of 24 valence electrons. That's my budget. All right, now everything gets connected by single bonds to the sulfur because I bolded it for you. Aren't I nice? And how many have I spent? I spent 2, 4, 6 of my valence electrons have been spent. So now I'm going to fill up the outside. And I will always have enough to fill up the outside. Everything goes in pairs. So I'm going to fill up one outer atom at a time in pairs. Pair, pair, pair. All right, I count out how many electrons I've spent. There's 6 on each oxygen from the lone pairs, and then another 6 connecting to the sulfur. So I have spent 24 valence electrons. My budget is spent. So that means I have to skip step 4. Now, let me see how that sulfur is doing. So I'm going to check out sulfur here. So I look at sulfur and I go, oh, sulfur only has 6 valence electrons. So you know what? I'm going to have to share to that sulfur. So now I'm on step 5. I'm going to share a pair. Everything moves in pairs. Share. Oops, I shared too many pairs. I got all excited. Let me erase that. All excited. Let's see if I can do that without. Oh, wee! All right. Oh, came out right. Okay, there we are. Okay, we're good. So I'm only going to be sharing one pair. And so now I end up with S, double bond O, O. I have my electrons. And my electrons. You know what? I don't like that drawing. I'm going to redo that. Okay, now I have a double bond. Okay, and then another single bond to an oxygen. I could have actually made that double bond to any one of the oxygens. I just happened to choose the one on the left. You could have shared from the bottom. You could have shared from the right. It's fine. Okay, so whatever you want to do on that. All right, now this next one, we're going to count the valence electrons, but then I'm going to have you try to draw the structure. So we have 4 from the carbon plus 4 times 7 from the chlorine atoms for a total of 32 electrons. So I am going to pause, all right? And you are going to draw the structure. Okay, let's see how you did. So you should have had carbon. So I'm going to do this very quickly for you. Off to a good start using hydrogen instead of Cl4. With 4 chlorines around it. Now we're going to fill up each one of the outside atoms. Notice I'm always doing everything in pairs. All right. Now, let's see if all the atoms have the correct number of electrons. I look at the carbon. There are 4 single bonds, so carbon is good. I look at the chlorines, and there's 8 electrons around each of the chlorines. So we're actually done with this structure right here. The next one that we are going to do is a polyatomic ion, CO3 2-. And the tricky thing here is counting the number of valence electrons. So we have 4 from the carbon plus 3 times 6 from the oxygen. But then we're going to add an extra 2, and that comes from the 2-. So when we total up how many electrons we have here, we have a total of 24 valence electrons. So we're going to connect everything to the central carbon atom. And I'm going to start putting these steps all together, okay? Now we're going to fill up the outside atoms. And I count to see how many of my electrons I have used. At this point, I've used 24 valence electrons. So I don't have any more electrons left that I can spend. So I look at that central atom and I go, oh, carbon's only got 6 electrons there. Carbon needs 2 more valence electrons. So at this point, I'm going to share a pair. All right. And let's redraw what we have. So I've shared a pair. Everything else stays just the same. Okay, and there is the carbonate polyatomic. And there's one little thing that we do after we're all done. We put a bracket around it, and then we say the whole thing has a 2- charge. So that everybody goes, oh, that's the polyatomic carbonate ion. We're going to do 2 more structures, and then you guys are going to be ready to do some practice on your own. The first one is SO2. So we have 6 plus 2 times 6 for a total of 18 valence electrons. Sulfur is going to go in the middle. We have spent 4 valence electrons so far. We're going to fill up the outsider atoms. That gets us up to 8. All right, now we're up to 16 valence electrons. We still need more on sulfur because sulfur only has 4 right now. We still have 2 left, so we're going to plop 2 on. There we go. Sulfur still only has 2 electrons. So what we are going to have to do is to share a pair. All right. So notice sulfur only has 6 valence electrons. It must have 8 in the final structure. So we're going to share a pair. And I'll go ahead and redraw this. Don't forget you get a little lone pair up there on the sulfur. And there is our shared pair. So that is sulfur dioxide. We're going to do one last one, and that's nitrogen. So nitrogen has 2 times 5 for a total of 10 electrons. Now, maybe you remember what it looks like. Actually, let me clarify. This is valence electrons. But let's say we're following the rules. We're going to say that one of these is the central atom. We'll just say the first one's in the center, and then we're going to follow the rules, okay? So we've spent 2 electrons. Well, now we're going to fill up the outside atoms. Yep, that's the outside. So that gets us up to 8 electrons. And then we're going to say this one's the inside. Okay, that got us up to 10 electrons. But that first nitrogen is not happy. It only has 4 electrons. So we go, okay, we're going to share. And we share a pair from the top. And we share a pair from the bottom. And we end up with nitrogen being triple bonded, which maybe you remembered that's what it was like anyway. Okay, so now it is time for you guys to do some practice. So we're going to stop.